So we started off talking about what's a radian, and so you've already seen this before, but just to go over it one more time, it's the angle made when you take the radius and you wrap it around the circle. So what I'm currently talking about is this right here. That did not show up. Try again. This piece right here. The angle created is called a radian. We talked about how radians are about 57.2958 degrees. And degrees are better when you're doing everyday things, but radians are better when you use math. So that's why we're using radian. Some other things we talked about, a central angle is an angle that has its vertex at the center of a circle. So this right here, this angle, is considered the central angle. An arc length is the distance along the arc. And so if we were talking about arc length, we would be talking about this right here. And we said when the intercepted arc's length is equal to the radius, the measure of the central angle is 1 radian. One of the first things we learned was radian measure. So the formula you're going to use is theta. Theta represents the central angle in radians, and then that equals S divided by R. S is arc length, R is radius. And then I just put, remember the formula only works if S and R are in the same unit. So if they're not, you would need to do a conversion. The really nice thing about being at home is you can just type it into Google and ask Google what the conversion is, and that's fine with me. So then I'm just going to do like one example of each with you since we've technically already learned all of this. So this example said, find the measure in radians of a central angle that intercepts an arc of length S on a circle with radius R. So you're just going to plug these in. So theta equals, and then S goes on top, R goes on the bottom. The centimeters cancel, that's why they have to be in the same units because radians don't have a unit. 2 over 20 is really 1 over 10, or you could get a decimal. It really doesn't matter to me either way. So I'm just going to leave it like this. And this would be in radians. We also learned how to convert between degrees and radians. So if you're going to convert degrees to radians, you would use this formula here. So you would multiply the degree measure by pi over 180. So first example, convert 30 degrees to radians, and then it says leave your answer in terms of pi. Remember, this means pi will just be in the answer. So I'm going to do 30 times pi over 180. You can just make 30 a fraction. Multiply across the numerator, so that's 30 pi. Across the denominator, that's 180. And then you just want to simplify your fraction. I believe it's 1/6. That would simplify to just be pi over 6. And you would just leave it like this because we want pi to be in the answer. Going the opposite direction, if you're going to convert radian to degree, you multiply the degree measure. Sorry, that should say the radian measure. Let me cross that off. By 180 over pi. So this time, pi over 4 times 180 over pi. You can just cancel your pi's out. You get 180 divided by 4. And if I type that into a calculator, it's 45 degrees. We also, in this chapter, found arc length. So again, just a formula. It says S equals R times theta. S is the arc length. R is radius. Theta is the central angle in radians. So it says find the exact length of the arc made by the indicated central angle and radius of each circle. So you're just going to take those and plug them in. So S equals 5 times 4. And so you would get 20. The only thing you would need to be really careful about is if this is in degrees, you would have to convert first and then plug it in. So if theta is in degrees, and you would just convert to radians doing exactly what we did on the last example. All right, last thing we did in this chapter so far before we got to speed, which again I'm going to do tomorrow, is finding area of a sector. So there's just two formulas depending on if theta is in radians or degrees. The only difference really is this will convert to radians for you, so they just plug it into the formula. So the first example says find the area of the sector. If you look, since this has no label, it's in radians. So I'm going to use this formula here. So I just plug in area equals 1/2. R is 3 squared times pi over 5. I like to just write everything as a fraction and just multiply across. So this would really be 3 squared is 9. I can write that as 9 over 1. And then I can just multiply straight across the numerator. So 1 times 9 times pi is 9 pi. 2 times 1 times 5 is 10. If you look up here, it says round to 3 digits. So I'm going to type pi into the calculator. And I get 2.8274. So I'm just going to write 2.827. The bottom one, the only difference is this is in degrees, so I'm going to use this formula on the right. So again, just plug everything in right where it goes. A equals 1/2, 3 squared, theta is 27, and then this pi over 180 converts to radians for you. So again, 3 squared is 9. I'll just write it as 9 over 1. I'm going to write as 27 over 1. Pi over 180. When I multiply, I get a number 243 pi on top, 360 on the bottom, and then again you just type that into your calculator and round to 3 digits. So I'm kind of out of room, I'm going to write it sideways. 2.121.